Good day, everyone. Today, in this recording, we're going to discuss about all the different sailing. So, this recording is only a quick recap of all the sailing. So, before you view this, you must first view and understand all the videos I've shown above, so that you have the idea, because this is only a quick recap. I will not do all the basic because the basics are discussed in these videos. So again, this is just a quick recap. For full understanding, you must first view the videos above before you proceed here. So I want to mention that the summary of formula is here. If you click it, this will be the summary of formula, and recap. The table is here, and the recap of sailings. When you click it, this will be the one. So again, as a recap, the purpose of sailing refers to a mathematical solution of problems involving finding the distance, the courses from one known point to another. So that is sailing. There are different kinds of sailing: plain, parallel, Mercator, mid-latitude. So plain sailing solves problems involving a single course and distance, difference of latitude and departure, in which the Earth is regarded as a plane surface. So that is just only a recap. Again, I trust that the video already explained and even showed more clearly what is plain sailing. So having said that, we proceed that as a summation, this is the formula for plain sailing. So always we refer to this formula. This can be interchanged, but you always go back with this formula. So having said that, we proceed with the problem. Uh, Find the course and distance between the following position by plain sailing. So this is the two position A, position B. Latitude 37 degrees 01 minutes north, longitude 009 degrees 00 minutes west. This is the arrival position, 36 degrees 11 minutes north, 00 degrees 02 minutes west. So first things first, we take the DLAT and DLO. So again, if you have difficulty in DLAT DLO, you can always refer to the previous video. But I trust you're already familiar with this because it's discussed in uh, the prerequisite navigation. So I will just have a quick rundown regarding DLAT DLO. So if you have difficulty, always refer to the previous video. So here, A and B, the DLAT. Example, in this illustration, because it is going south and same name, we just subtract. So we have 15 minutes south. DLO, because it is going east, so we subtract it. And that's why we take 02 degrees 58 minutes east. So after that, we take the mean latitude. Up to you, you can add this to latitude and divide by 2. I trust that is also explained in the video. Also, you can divide the DLAT and add from the departure of latitude. So that's already, we can take the mean latitude, which is 36 degrees and 30 minutes north. So after that, third step, we take the formula departure equals DLO times cos mean latitude. So we take this uh, formula cos mean latitude from here. We transmute that and we arrive at this formula. So by substitution, 178, which is in minutes, and 36 degrees 36 minutes. So you times that and you arrive at this answer, 142.9 miles. So that is the departure. So the next step is we take this formula, tan course equals departure over DLAT. So we take, remember, again going back to this formula. So by substitution also, we arrive at this course. So this is quadrantal angle. Always remember, we use quadrantal angle in computation for the sailings. So south because south DLAT, and east because east is the DLO. So finally, the distance, which also taken from here, is equals departure over sine co. Departure is 142.9 and sine is 70.715 minutes. So by calculation, we arrive at this answer. So having said that, we already answered the course and the distance. So this is the course and this is the distance. Again, we always refer going back to this formula because bali-bali regional slopinometry. So next one, we proceed to parallel sailing. So this is the formula for parallel sailing. So in parallel sailing, it is understood that the ship is on the same parallel latitude. So parehas siya latitude, only longitude ang diferensya as per definition. So more main formula ang inyong So having said that, let's go to a sample problem. Find the total distance traveled by a vessel steaming due west from latitude 38 degrees north and longitude 35 degrees 27 minutes west until she arrives at longitude 120 degrees 17 minutes west. So this is the latitude as one latitude only because it's parallel, and we take the d long. So because it's going west, we just subtract the d long 120 from 380. So we have this d long times 60 to get the miles. So again, this formula we use. So by substitution, we arrive at this distance, and therefore we already answered the question. So again, in parallel sailing, you just use this formula, and by substitution, you can have your answer. So that's it. And Mercator sailing, we use this formula, tan course d over dmp. dmp is this one. So as a reminder, how you take the d-low is also the same in how you take the DMP. So how we take the DMP, we go to this table. In ORIS table, you can download. You can just click it and it will download automatically. So I already downloaded this. So this is the original parts. So it started in page 132. So for example, 29 degrees 1 minute. So this is the original part. So in this case, in the example, 49 degrees 10 minutes. So here 49 degrees 10 minutes, so 3379.63. So 3379.6, so that is the original part. So because the DLAT is subtracted, so same as well in DMP, so you subtract. So again, first take the DLAT and then take the DMPs from the table. Then how you take the DLAT is also how you take the DMP. So after that, you times by 60, then you get the DLAT in minutes. So the third step, you get the D-low, and then after that you apply the formula, which is this one. D-low is 860, DMP 18263, so that is equals this number, and then you shift tan negative, you will arrive with this answer, 25.1 minutes and quadrantal course. So south and west. So after that, you take the distance, you use the formula on the plain sailing. So distance can be equals to DLAT over cosine course. So DLAT is 1435 and cosine course is 25.17. So by calculation, you get the distance. So we already answered this, the true course and the distance. This is the course and this is the distance. So again, you just refer to this formula, and MP you can take from the table. Finally, we have the mid-latitude sailing. Mid-latitude sailing also just the same as the Mercator sailing, only different formulas, but it's up to the seaman which wants to use, but it's just an alternative to Mercator sailing. The answer is the difference is almost negligible. So this is the formula for mid-latitude sailing. P d low times cos Lm. Lm is mean latitude, and this is for the course, P equal over d lat. So in here, I use the same problem for simple illustration. So the same, we take the d lat and we take the d long. Also the same here. The answer is the same. After that, we take the mean latitude. We just add and divide by 2. And after that, we use the formula. So by substitution, we arrive at 684.94. So this one, we already have the P, and we take this formula for the course. So just simply substitution, we arrive at this course. So as you can see, it's almost the same as Mercator, which is 2.5. The distance, you use the plain sailing for the distance. So d lat, cosine course, substitution, we use this because we use mid lat. So the answer is 1591. So almost the same. So again, this middle latitude is just an alternative to Mercator sailing. That's why the answer is almost negligible. So in summary, the 4 sailings I've discussed is plain, parallel, Mercator, and mid-lat. Plain and parallel, you use less than 600 nautical miles distance. Mercator and mid-latitude you use if beyond that distance. So para di mo if you cannot be confused, you just always refer to the formula. And after that, magbali-bali na yan. That's why I summarize the formula. And again, you can always view the prerequisite video because this tutorial is only meant for a recap. Okay, I trust na mo idea if nakakita na ba ito. So that's all with regards to the sailing. If you have any questions, you can always ask me.